Hi, these are the answers for this week's homework on the Core 1 questions, which were quite difficult. In this first question, as you can see, the difficulty is making sure you remember how to multiply accurately numbers which have an integer in front of the square root. So if you look at part B over here, this is quite a hard calculation to get right. Check your answers, making sure, for instance, when you're multiplying this number with this number, you'd multiply the two integers, so you'd get 12, and you'd multiply the two square root numbers. So here initially it's been written as 12 root 9. That will simplify further though to 36, because 12 times 3 is 36. You can see with this second one, the number in front of the root 7 is minus 1. 4 times minus 1 is minus 4, and then root 21, which is what we've written in this box over here. Check your answers. Part A, maybe the difficulty might be misinterpreting it. This is not a bracket you're expanding, so again, writing it out like this makes sense. And then 3 times 3, square root of 3 times square root of 3 gives 9 times 3, with a final answer over there. On this question, which is about circles, it's very important to get the initial equation right so that you can get the rest of the question right. Make sure you learn circle equations effectively. So you can see here, when the centre is minus 3 as an x-coordinate, the bracket will be an x plus 3 and a y minus 1. And here where you have r squared, we'd have 13 because the radius is root 13. If you want to check this, just think yourself, if you covered up the information about the radius and the centre, what the centre and radius of this equation would be. They obviously want you to expand this to get their answer in part 2. To work out later in the question, for instance here, where it cuts the y-axis, as with any graph, we're going to be using the principle that the x-coordinate will be 0 on the y-axis. So you can see over here, what we've done is this. That creates this equation when we put it into the circle equation, which creates a quadratic, which we solve. We're not asked for the x-coordinates, we're asked for the distance between them. Draw a sketch and you'll see the distance between these numbers is this figure. Final parts of this question, you need to make sure you understand how to work out whether a point lies inside or outside the circle. Working out the distance between the centre and the point is probably the easiest, showing it's either going to be bigger than the radius or smaller than the radius. Make sure you're happy working out the equation of a tangent. That's a very particular method with a circle, not the same method as a curve, and I'll just show you. So as you can see over here, working out the equation of a tangent, you're basing it on working out the gradient of the centre to that point, and then the tangent is at right angles to the circle. So the gradient of C to D, centre to point D, is that. So your tangent is going to have a gradient which is the negative reciprocal. Then we're putting it into a straight line equation. Look at this method of the easiest way to deal with line equations with a fraction for a gradient. You multiply the bottom number over here to this side, both parts of that, the entire left hand side multiplied by the 3, and the minus 2 stays on this side, and then it's just. This is quite a difficult question. The first part, you need to be able to complete the square with a negative x squared, as over here. If you have a look at the solution, you can see a good way to do it is to first start by maybe writing the quadratic with the minus x squared at the end, and then to take out a minus 1 as a common factor, so this becomes plus 10. There should be a plus 10x there, bit of a mistake there, plus x squared. Then you create your square bracket, so that's going to be x plus 5, and you always take away the square number. And before you combine that minus 25 with the 4, you need to multiply out with this negative 1. So that becomes minus square bracket squared, and minus 1 times minus 25 is plus 25, then is combined with the 4 to make this. And if you were asked further questions on this, like the line of symmetry, you may need to remember this is a graph shaped that way, and the vertex is still going to be minus 5 and plus 29 as the y coordinate. In the second part of this question, you can see you're going to be asked to do the intersection of a line and a curve. So start by putting y equal to y, and then they obtain this, show that line by rearranging that equation and taking out x as a common factor. So in this final part over here, as you can see, they've put the two equations equal to each other, multiplied out, taken everything to one side, and then if you take out x as a common factor, in fact they've taken out 2x as a common factor, you get there, show that line. In the last part of the question, they want you to take this quadratic here, and from it, if you're told it has two distinct roots, to show this quadratic inequality. So to do that part of the question, they've started by identifying that if it's got two distinct roots, the discriminant is greater than 0. Then they've identified what a, b and c are for that quadratic, which is this line. They've multiplied it out. Again, be very careful over here. As you can see, you've got minus signs. So they've taken it in steps to do that part there first, and then multiplied it out with care to get plus 52k plus 16. That could be a common error on this. In the final step, they've divided by 4 to get the required line. And in the final part of this question, you can see what they've done is solve that quadratic inequality following all the steps, including factorizing, drawing a sketch, identifying the critical values on the sketch, shading the correct part of the sketch, which they haven't done here, but they should do, and then obviously at the end writing down the inequality symbol, because we're looking at the part of the graph which is below the x-axis. Question over here, you've got to form various inequalities. The first part, the perimeter is greater than 30 meters, so the perimeter, if it's a rectangle, will be 2x, x plus this, plus this, plus this. You can see that results in this line, which simplifies to that, and we know that's greater than 30, and that will simplify further to the final answer. The area needs to be less than 96, so here again they've started with the area question. Area of a rectangle, length times width, that's going to be less than 96. Multiply out, simplify, and you get the required line. Part C is about solving the quadratic inequality. So as you can see in the last part here in part C, factorize, sketch, information on the sketch before you write down your final answer. Part D is the hardest part of this question. This requires you to combine information from C and from here as well, from part B. Because from part D, you've worked out that x must be less than 8. And obviously it's bigger than 0 because it represents a length in a garden. And here, if you solve this further, you will get x is bigger than 5.5. So you get your final line, which is in between those two numbers. In this question over here, standard question about a box and surface area and volume. The first part of the question involves total surface area of the box is 32. Make sure you understand whether the box has a top or not. This one does. So you need to show this line of working out over here. As you can see, surface area will be the sides of the box. Okay, so surface area of this box for one side, the next face, another face, another face, and the other two faces all together simplifies to this, and you get the required line of working out. To show the volume question, you need to start with this result over here and rearrange it to get y equals something. So as you can see, that's what they've done on this side over here. rearrange that equation to eventually get y equals something. The volume of a box is going to be the three dimensions multiplied together, but they're now substituting this letter y with this result from part 1, which gives this line, which will simplify to that line. The best way to simplify this is to multiply out the top, 48x squared minus 9x4, and both of them individually are divided by 4x, which then simplifies to that. The rest of the question in this particular case is fairly straightforward. I'll simply show you the answers for that. As you can see, differentiating, and then in the next part they give you the value for the actual x stationary value, so you're testing whether that gives a gradient which is equal to 0. The only difficulty here is dealing with this fraction calculation over on this side. You want to square the fraction first, then you want to probably divide it by 4 and then multiply by 27. Either way, you should be able to show it equals 0. Make sure you write a concluding statement in these sorts of questions. In the final part of the question, you have to work out the second derivative. In this one, forgetting that minus sign there might have been a common error. They expect you to show how you're using your stationary value and what answer it's given, which is minus 18, and then to make a statement like this, where you're saying that the second derivative is negative and therefore make a conclusion. In this case, it's a maximum point. In the first part of this question, you need to show that y is increasing and show this statement. The starting point is understanding the concept of increasing and decreasing. A graph is increasing when the gradient is positive. So your starting statement is going to be that the gradient is positive, which means this is greater than 0, and all they've done is divided it by 2, and then they've also taken things to the other side to get the final result. In other words, they've divided by -1 as well. In the next part of the question, you have to solve a quadratic inequality, and as you can see, that is fairly straightforward. In the last part of this question, the question is asking you to consider a point P and to verify the tangent is parallel to the x-axis. The key to this is if the tangent is parallel to the x-axis, it's got a gradient of 0. Try and visualize that in your minds. So you have to show that this coordinate has a gradient of 0. And in this part over here, you have to also look at another to find the equation of a normal at Q, and also the equation of that tangent at P, and find their points of intersection. So if we look at these two parts over here, first demonstrate that this point gives a gradient of 0. And when you've shown it's got a gradient of 0, make sure you write that concluding statement. In the final part of this question, as you can see, what we're going to do is first find the gradient of the tangent at Q, and then the gradient of the normal. In other words, this is the equation of that normal. The equation of the tangent is just going to be y equals 3, so horizontal line going through 3 on the y-axis, so its gradient will be that. Then you need to consider how to solve these two equations simultaneously to find the point of intersection, and you can see the easiest is to make this substitution here. Replace the letter y with the number 3. As you can see, the result of doing that is pretty simple. Given an x value, make sure you answer the question. They want the whole coordinate for r.